All right, let's go ahead and get started. Thank you everyone for joining us today for the Residential Inspections webinar. This webinar will be recorded and the recording is sent out to all attendees. If there are any issues with audio, please write me in the chat. My name is Erica Dwello and I'm a project manager for NRESCO. And this series is sponsored by the Colorado Energy Office with training materials created by BuildTank. So Robbie and I have been working with the Colorado Energy Office for a couple of years now, and we've been providing trainings just like this one. Here we've got just 4 more webinars in this series after today. So be sure to join us for next week. Shauna and I will be presenting on the code adoption toolkit and writing proposals and different things like that. So if you would like to register, a link will be sent out in a follow-up email. So feel free to check that out. And then in addition, we also offer technical assistance and group trainings. If you have any questions about that, feel free to write me an email and we can set you up with a subject matter expert and help your jurisdiction advance energy codes. And then, as I said before, there is a code adoption toolkit that we've created. We've been adding things to. So make sure to check that out. And then I'll also review it next week in our webinar session. And then lastly, we do want to encourage questions throughout. So please feel free to use that Q&A function at the bottom of your screen. And I'll let Robbie know at the end of the presentation. We've also incorporated some polling questions for the audience. So keep an eye out for that. And I'm actually going to go ahead and launch our first poll and see just who is in the room. So if you wouldn't mind taking a second to fill that out. But so today our presenter is Robbie Schwartz. He's the founder of BuildTank, and he created it to be a practical building think tank to do research, education, and work with builders to ensure that their homes not only comply with codes and programs, but also perform. So with that, Robbie, I'll let you take it from here. And oh yeah, I'll go ahead and end the polling now and share the results.
Great. It looks like the majority of people are building officials. And then there are a fair amount of other. Maybe if somebody who falls in that other category wants to type in the chat box what your profession is, it'd be great to have a good understanding of that. Thank you, Erica. My name's Robbie Schwartz, and I'll be your presenter today. I am going to stop my video sharing so that you can concentrate on the slides and not my lovely face. And today we're going to be talking about residential Iacc inspections and kind of the scope of what needs to be looked at when you're looking at compliance with Iacc. So we'll be talking a little bit about what inspections are, what requirements are, what must be inspected, and then we'll have some examples of things that you need to look at when you're doing field inspections. So to begin with regards to what does inspection actually mean? When you look it up, it's talking about this careful examination or scrutinization of a specific item. It can be thought of as verification, or it can be used to determine compliance there as well. And then we talk a little bit about types of inspections, and there's pre-production inspections, which I think is analogous to the plans examination that we go through in the process of demonstrating compliance with the code for a house. There's inline inspections, which would be analogous to field inspections, pre-drywall inspections, for example. Re-inspections would be kind of in the process of building something, or if you're talking about a manufacturing scenario. And the reality is that building a house is a manufacturing scenario. It's just done outside, in a community versus a manufacturing plant itself. And then final inspections, these are the inspections that are done before the certificate of occupancy is released, and a lot of that information is needed in order to actually release that certificate of occupancy. So then we need to think about, what's the next thing that comes up from a code perspective, and that's these things that are requirements. So things that are compulsory, things that are necessary, things that you have to do because the code says that in order to comply with it, these things have to happen in the house. A lot of these requirements in the past, before the 2021 Iecc, we called those things mandatory. But there were actually things in the prescriptive path of the code that were also mandatory as well, there, regardless of the compliance path that you're choosing. So we need to talk a little bit about terminology. So the first thing with regards to requirements is that the word mandatory has been removed from the Iecc in the 2021 cycle there. And it's been replaced by basically just this word requirements. It's really, the meaning is roughly the same. They are mandatory. They are things that you have to do. But these requirements, where they're found, is the idea is that it's been made more simple and more straightforward, because there were some things that were not labeled in the prescriptive section of the code as mandatory that turned out to actually be mandatory from the perspective of the code when you're complying using a non-prescriptive path of compliance in the code. And I'll show you some of those here in a second. So the next question really is, what are these prescriptive requirements? So prescriptive requirements, those are things that can't be traded off, except when you're using the UA compliance pathway, which is embedded in that prescriptive path there as well. Requirements that must be met using other compliance paths, including the requirements that are now in tables there. Those are things that could be considered prescriptive requirements as well. So you'll see as we move forward here that a lot of the requirements that you're inspecting to are embedded in this prescriptive section of the code, but have been moved into a table in the performance sections of the code. That's sections R405 and 406, so that people don't forget that these things are actually a requirement of the code. So we have these prescriptive requirements, these things that we have to do regardless of the pathway. And then we have this performance approach. And the performance approach brings in the notion of a trade-off. And a trade-off is used to meet specific prescriptive requirements of the code unless there is a way to trade off that. So really what we're able to trade off, and the only things that we're trading off, are U values and R values in the building envelope. All the other requirements are how you actually install something there, how that works. So diving into trade-offs in a little bit more depth here, we see that a trade-off really refers to putting something more in one piece of the assembly of the house so that we can put something less in another piece of the house while maintaining an energy performance balance in that house. So the code is asking us to achieve a certain level of performance, a certain level of energy efficiency in that house. And the ability to trade things off gives us a little bit more flexibility in determining how we're going to build that house. So again, you can trade off U values and house tightness and duct leakage and those types of things, but you can't change the overall energy balance in that house. You have to achieve what the code is trying to achieve. So if we look at this picture of this kind of seesaw here with the balls on it, you can think of the blue ball maybe as attic insulation. And I'm going to put in R38 here in climate zone 5. And the new requirement in climate zone 5 is an R60 attic there. And you can think of the three silver balls that are balancing out the equation here, maybe representing better windows or a tighter house or reduced duct leakage or something. And in that way, I can trade off less R value in my attic for better performance in my windows and in my air tightness and in my duct leakage requirements there, while achieving that energy balance in the house here. So that's what the trade-offs does. And that's what the trade-offs, and that's ultimately how the trade-offs give us greater flexibility in how we determine how a builder wants to build their house ultimately. So what we see here in the prescriptive sections of the code is we have these prescriptive requirements, these things that are mandatory that have to happen. For example, you have to install attic Eve Baffles if you have a ventilated attic. You have to install a vapor retarder over the crawl space dirt floor. When you're installing floor insulation in attics, there are specific requirements for how you install that insulation. Now, this is where the confusion used to happen, is that there are also requirements for R value. And so you can trade off the R value component, but you can't trade off how the code says you need to install that R value. So again, in that floor system in Colorado here on the Front Range, Climate Zone 5, it says I have to install an R30 in that floor system. And then it tells me 3 different ways of how I can install that insulation. Well, I can trade off the R value part of it, but I have to choose one of those 3 ways to install it, and I have to stick with that. I have to do that, and that's ultimately what we're inspecting there. So from an inspection perspective, again, we might be looking at both the R value and how it's been installed. And that's really kind of changed our thought process when we start talking about true inspections here. But before we get to field inspections, we want to make sure that everybody realizes that a plan review is a type of inspection. You're reviewing, you're verifying what they are proposing to put in that house to achieve compliance. And on the Colorado Energy Office's website, there is a plans examiner checklist for the 2018 Iacc and the 2015 I thought the 2015 commercial and 18 commercial, but on the residential side, we've updated it to just have the 2018. So if you aren't on the 2018 yet, this is still a very useful document to go to. It looks something like this, and it just kind of gives you a checklist format to go through the plan sets to make sure that all of these details are looked at. Are being addressed in those plans and that proposal. You can think of that plan basically as a proposal for what they plan to do, how they plan to build that house. And then the field part, the field inspection comes to basically ensure that they've done what they propose to do. Okay, so let's go to our second poll question here. The poll question says, how many compliance paths are there? I'll give you a few seconds here to look at that and answer the question here. And what's interesting about these different compliance paths is that there are, in certain sections, there are a number of compliance paths that are embedded within one section. So it'll be interesting to see how well we understand that. Okay, here we go. So the majority of people say that there are 3 compliance paths. The next is 4 and the next is 5. So let's look at these compliance paths in a little bit more detail and see how many there actually are. So when we look at the prescriptive U value and R value compliance paths, there are actually 3 compliance paths. There's one that's related to the U value, that is the assembly, and then there are 2 that are related to the R value. There's one R value approach that's assembly based, and there's one R value approach that's cavity insulation based there. And then we have the prescriptive U value compliance pathway. So really in the prescriptive section, there are 4 pathways to demonstrate compliance that are described in that section alone. Then we have the total building performance pathway, which used to be called the simulated performance pathway before the 2021 IECC. We have the energy rating index pathway there. That's not being used really as it's defined in the code anyway. And then, most of us probably don't really realize that there's a tropical climate pathway just for those climate zones that are considered tropical as well. So just there, we have 3 plus 1. So we have 7 compliance pathways just there. And then you might consider, some people might consider these additional energy efficiency requirements that have been added in the 2021 IECC as potentially an additional compliance pathway. Really, these additional energy features are features that have to be added to those compliance pathways. So this section establishes these additional compliance approaches, and in the prescriptive path, it's pretty straightforward. So if you're using the U value or the R value or the area weighted U value approaches, you just need to choose one of the efficiency packages that are laid out in the section R408. So that's a new chapter, a new section that's been added to the code there. It's not really a chapter, it's just a new section that's been added to the code. In the performance compliance pathway, you need to either choose one of the efficiency packages that are laid out there. However, you can't model that additional efficiency to demonstrate compliance. So you still have to demonstrate that you're doing that package, but again, it's not going to be calculated when you're calculating the cost compliance mechanism to demonstrate compliance. Or you can do a cost compliance that demonstrates that you're 5% better than the reference design. And with the energy rating index, they leverage that 5% better as well. So you don't actually have to do one of those prescriptive packages. You just need to demonstrate that you're 5% better than the reference home is for the 2021 IECC. Now, these additional efficiency packages include envelope performance, better HVAC equipment, more efficient water and heating systems, more efficient HVAC delivery systems, or improved air sealing and ventilation systems in that house. So these are things that need to be inspected when we're looking at that house there. So as we start moving to thinking about the true field inspections there, we see that these different pathways through the code are looking for us to inspect certain things. So we need to remember that code officials or the authority having jurisdiction has the possibility of allowing a third party to do these inspections. And it's really important to have clear and accurate communication between the third party and the authority having jurisdiction so that everybody knows what exactly they're supposed to be inspecting and looking at to demonstrate compliance, because sometimes jurisdictions think that a third party is looking at something and the third party didn't realize that that's actually what they're supposed to be looking at. This has been demonstrated and really came to light with the introduction of the energy rating index pathway in the code, because energy raters were going out there creating the energy rating index score, but they didn't also realize that some jurisdictions were asking them to do other inspections on the house, including the air barrier and insulation inspections that were out there. And we have to remember the air leakage and duct leakage and ventilation testing as well. With the simulated performance path or the building performance path, it's kind of the similar, the authority having jurisdiction and the third party can do the inspections, HVAC requirements, and then those diagnostic testing as well. Now, the difference when we start getting into the true performance paths are that a document has to be created, a compliance document has to be created to get your certificate, to get your building permit. So it's a proposed document. and then a confirmed document has to be delivered for the certificate of occupancy. Therefore, the third party is probably going to go out there regardless of if the authority having jurisdiction is also doing the inspections, because the only way the third party can create that final confirmed cost compliance report is to see what's happened in the field and inspect what's happened in the field during the course of construction there. And that's true with the energy rating index pathway as well. If the rater or whoever the third party is doing their work correctly. And what's new in the 2021 Iecc is that this process of reporting and creating the cost compliance report and the energy rating index pathway is been spelled out specifically what's needed for permitting and what's needed for releasing the certificate of occupancy. So other requirements that begin being displayed in Chapter 4 in section R402 is in this building thermal envelope section. This is where all the prescriptive stuff used to be laid out, and it used to be in essence called the prescriptive pathway. They actually removed the word prescriptive as well as mandatory from the code, and now everything's just requirements there. But this is where the vapor retarder requirement is housed in the energy code, and it's where it would forward you over to the IRC to look at those things as well. And so you need to look at those. And then it also talks about the different alternative approaches that you can demonstrate compliance using what we generally call the prescriptive path of the code. Now, regardless of the compliance path that you're using, these features, I guess, of how you install specific features in the home are outlined in this section of the code, this R402 section of the code. So it talks about how the installation shall meet the specific requirements, and then it goes through ceilings and attic eave baffles and mass walls and floor systems and basements and slab-on grades, all the way through sunrooms and heated garage insulation details that are called out in this section. So there are 12 things here that you need to inspect to, not only from an R value perspective, but also a lot of installation guidance and requirements are embedded in this section of the code here. So this is embedded in what we call the prescriptive section of the code, that prescriptive compliance path. And then we have these other compliance paths, really excluding the UA compliance paths that are performance-based, and then those energy compliances. And in those performance paths, the true total building performance and the energy rating index paths, the code has created these certificates, these tables here. These are the requirements that have been taken out of the section 402, that prescriptive section, put into this table so it's crystal clear that these are requirements for these sections, these performance sections of the code as well, in order to demonstrate compliance. So going back to, you can see about 4 rows down, attic eave baffles, for example. Just because you're using a performance pathway for compliance, if you're doing a ventilated attic with soffit vents and a ridge vent, you still need to install the attic eave baffle. And that's where the confusion came in earlier versions of the Iecc, is that some people felt that if I'm doing the performance approach, then I don't need to install eave baffles and those types of things. And that ultimately isn't true here. So all of these things that are listed in these tables, in essence, become mandatory requirements for these pathways. And they're the same requirements that are required in the prescriptive section. Therefore, all of these things are required regardless of the pathway that you're choosing to demonstrate compliance ultimately. The only difference is that you're now able to trade off R values and U values when you move to these more performance-based compliance pathways here. So when we're inspecting, again, this is one of the tables that we're inspecting to that gives us a lot of requirements to think about when we're going out in the field to inspect. And this table can be thought of as a checklist. And the better you understand this table, the better your ability is to achieve the air leakage requirements of the code. So the table talks about the different components down the left-hand side. It talks about the air barrier criterias and the installation of insulation on the far side of the table. And it's been changed quite a bit in the 2021 Iecc. First, the name is changed, so it's now called the air barrier, air sealing, and insulation installation table. And then those sections that are underlined here have been changed as well in this table. Actually, all of the components on this slide here, from rim joist down to footnote B, have been rewritten in this table to be more clear what's required, and also to refer you back to those specific sections that are covering, for example, basement walls or rim joists or other sections that are discussed in more detail in that prescriptive section of the code. So besides these things in section R402 that we need to inspect to, there are also more and additional requirements that need to be tested and need to be looked at for verification of compliance. The first one comes actually in section R401 before we got to the different compliance paths. And this is the creation of this label or certificate that needs to be posted in the house. Now, there are some new things in the 2021 that need to be on this label. We have on-site PV production, we have ERI scores, we have the actual compliance pathway that needs to be added to these certificates. Although a lot of these certificates that are printed from softwares that are demonstrating compliance for the performance paths had some of this information before. The reality is that when you're using the prescriptive path, a lot of these certificates are being created by hand. So you need to ensure that these things are on there and are displayed properly here. Section 403 is talking about hot water pipe insulation. This is a mandatory requirement. In the past, before the 2021 Iecc, actually it was also made a mandatory requirement for the ERI pathway as well. So some of these things that are called out and displayed in the code only become a requirement if it's been installed. Now that's not necessarily true for pipe insulation, but for example, drain waste heat recovery, there's not a requirement to install drain waste heat recovery, but if you do see it in a house, then you need to look at this section and determine if it's being installed. So there are some things that are mandatory you have to install in the house, and other things that you don't have to install, but if the builder decides to install it, you have to follow the guidance that's given in the code, and you need to inspect to that guidance that's given in the code there. Then we have things like lighting that has changed. Now all permanently installed light fixtures have to be high efficacy lighting sources instead of a percentage of the lighting in it. And in the 2021, we need to also look at lighting controls. We didn't have to look at lighting controls before, and we didn't have to look at exterior lighting before either. So these are new things that we need to inspect to in the 2021 Iecc. Other things that continued in the 2021 were building framing cavities shall not be used as ducts or plenums. So when we have a code that may not be as clear as it should, or that there are potential ways out of doing that, we have to remember that the most restrictive requirement actually governs. And this comes up with this particular requirement because in the IRC and the IBC, there are sections that deal with Hvac plenums. And Hvac plenums are really talking about the space within a wall cavity where duct can be run. And it's being construed, however, that that plenum, that wall cavity, could actually be the duct. Well, this requirement in the Iecc is actually more specific, and it says that you can't use that plenum for a pressurized duct as displayed in this cavity, because you can see this return is returning some of the air from the house, but some of the air from the attic above on this ranch style house. So this is awfully in the summertime. This is when this picture was taken, it's extremely hot air that's returning back to the air conditioner to get reconditioned. And it can really impact the efficiency as well as the long-term durability of the HVAC system and potentially the air quality inside that house there. So again, just thinking about which requirement applies to a specific house, and if there's discrepancy between those requirements, the most restrictive actually should win out in that battle, in essence, between conflicting requirements there. Room containing fuel burning appliances. This is something that I don't think is inspected very well, potentially, but really any appliance that is a combustion-based appliance and the opening for the combustion. So if you have a atmospherically vented appliance is the best example, then that room, you need to build an airtight room that separates those appliances from the conditioned space of the house. And that room needs to include sealed doors that are fully gasketed, and all the insulation in the wall systems and floor systems that separate that space. Because in essence, you're saying that that atmospherically vented appliance is outside the building envelope there. So your building envelope is being constructed around that space. So you have air barrier details, you have insulation details, you have gasket details, all of these things that you need to be looking at to ensure that that fuel burning appliance is separated from the conditioned space of the house where the occupants will be living there. So that's a big inspection process for, you know, a small area of the house there. So those are kind of an outline of those details, and you can see that there's quite a bit there, but we also have these performance testing requirements in the code there. So let's ask our next kind of poll question here. How many performance tests are required by the 2021 Iecc? We'll get a question here, or the answers here. Okay, so the majority of people say 2 performance tests are required. A couple say that 3 are required. So let's look at that. So the blower door test is a requirement of the Iecc. So you have to determine how airtight the house is and if it met the requirement. Less than 3 air changes in our climate zone, here are 5, and less than 5 air changes in climate zones 1 and 2. We have a duct leakage requirement, testing requirement. And the reality is, although it's not spelled out specifically and very well, you not only have a total duct leakage requirement to be tested. But if you're using the performance pass, you have a duct leakage to outside testing requirement so that you can quantify the ability to trade off tighter ducts in the house that are leaking less air to the outside for maybe less insulation somewhere in the building envelope. So that now we have a total of 3 tests there if you're doing the performance pathways of the code. But if you're just doing the prescriptive pathways, we have 2 tests that are outlined. And the 2021 Iecc adds this additional test for testing ventilation systems and verifying that the flow that's achieved at our bath fans, our kitchen fans, and our whole house mechanical ventilation systems are actually pushing the air that's required. There is an exception to that for kitchen range hoods if it's ducted properly or in accordance to how it's laid out in the code here. But the reality is that most of these bath fans, for example, don't have the ability to actually push the required amount of air to ventilate that house, to get moisture out of the house well there. So in reality, there are 3 basic tests that are required in the Iecc, and then there's the 4th test, the duct leakage to outside test, if you're using the building performance path or the energy rating index pathway in the code. So if you haven't looked at it, there is a section in the Iecc that talks specifically about inspections that can kind of key you into the different inspections that have to happen in the house, from footings and framing and rough inspections to plumbing rough inspections to mechanical systems, final inspections, and it actually even outlines re-inspections in this section. And then if you go a little bit more into a little bit more detail in this section, you'll see that the framing section, for example, calls out some specific things that you need to be verifying there. Things like R values and their correct location. But look at that next section there. It says R values in their correct location and their proper installation. So remember that the code goes a long way to supplement manufactured instructions for how to install things. And there are some differences or some additions to what the manufacturers might say that would make that installation compliant or not with the code. Air leakage controls as well. Mechanical systems, it gets into needing to look at the system installation and the corresponding R values of the different components of that system, like R values of ducts in unconditioned space, the system's air leakage, so that duct leakage test, whole house ventilation, how it's been installed, and now we have to measure that as well. So when we look at these different things, we can see that we're starting to really focus on verification of performance. How are things installed so they actually work? So it changes the way that we should be looking at this inspection process. And potentially, one thing that I find helpful is asking 2 questions when I come across a component that I need to inspect for compliance with the code. The first question is fairly simple. Is it there? So in this case, I'm looking at this fan in the house, and yes, this fan is located in the bathroom. It's designed to get moisture up and out of that bathroom correctly in the right manner there. But I need to look at how that fan was actually installed, and does it have the ability to push the required amount of air? Now, this inspection is super important to do at this rough stage, because if I wait for the verification that comes at the end now with the 2021 Iecc, it becomes very, very difficult to actually get that fan to push 50 CFM of air and or to replace this ductwork so that it can push that 50 CFM of air. Another example would be insulation. I can't just walk into a house and say, yep, I see pink or blue or yellow or brown insulation in the wall systems here, I have to go a little bit deeper and look at how that insulation was installed, and is it being installed according to the code and the manufacturing instructions to actually perform and work here. Same with insulation and rim joist details. Now, there are two things that we're looking at here. We're not only looking at the insulation, but we're looking at the air sealing details that are called out in the insulation and air sealing table in that code. So if I can see air gaps directly to the outside, I can see that it's not being air sealed correctly. But I also have to know that we're looking at sealing the rim joist to the slab. We're looking at sealing, the sill plate to the slab. We're looking at sealing the rim board to the sill plate and the rim board to the subfloor. Those are all areas that are called out in the code to air seal. And then we have to insulate that cavity as well. We don't have to look for an interior air barrier system, but in the 2021 Iecc, it has been asked to ensure that that insulation maintains permanent contact with the exterior air barrier here. And you can see how easy it is to install a bat in that location that has a kind of a crescent shape so that the insulation isn't actually touching the surface that it's intended to insulate there. So it's there, but it's not working. So it would fail its inspection. HVAC inspections are something that hasn't been traditionally transferred to a third party at this point. But there are lots of things that we need to be looking at when we look at the HVAC system from this perspective of, is it there and does it actually work? First, no building cavities should be used, but are these ducts run and installed in such a way that you're actually going to be delivering the air that's being proposed to be delivered in that room there? So it's super important to look at installation as well as what's just been written down on the paper there. Here's another example from an insulation perspective. Did they actually split the bats around obstructions in the cavity? Are there gaps, voids, and compressions that's going to ruin the performance of this insulation in the assembly there? So again, we can't just look that it's there. We need to think about how it's been installed here. So there are some field inspection checklists to help guide you. These checklists are generally printed and turned in with the UA compliance path, the building performance path, or the energy rating index pathway of the code. Personally, I don't find them that helpful because you still need to understand the core requirements around that. It can be helpful for highlighting the R value of a specific assembly so you can determine if they've achieved that R value or not. But again, from the perspective of, was it installed correctly and in accordance to the manufacturing instructions and those additional things that are called out in the code? I don't know about these checklists so much, but they are a resource and you could take advantage of them. So let's look at some things that are maybe difficult to look at in the field from the perspective of a field inspection here. So these are drop ceilings there. In order to make a drop ceiling work, we need to think about the sequencing of the requirements that are required by the code here. So the code says that we need to install an air barrier on that exterior wall so that we don't have the ability to see that yellow insulation there. We've enclosed that air barrier, and we could talk a lot about the building science around that, but we just don't have time. We also need an air barrier on the bottom chord of the truss there. Then we can overframe the drop ceiling below there, and then we can insulate on top evenly across the attic plane there. And in that way, we have an assembly that is brought into the conditioned space. and will actually perform. So from, again, that perspective of, is it there and does it work? We need to do this inspection at a rough stage of construction to see if the framing has been done properly. And that brings up the point that the majority of these air barrier details that are described in the code are really the responsibility of the framer, and therefore it's at that rough inspection time frame where this inspection would happen there. Another one that's kind of difficult to inspect is this this requirement of the code. It says that we're actually allowed to reduce the R value of the material without doing a calculation. So we don't have to move to the UA compliance pathway or the building performance pathway. We can just derate or put in less R value if that R value is fully covering the top plate there. So we need to figure out how are we going to determine if the R value is going to cover the top plate, which means that we should probably be looking at this at a rough stage of construction. So anybody know how deep the insulation needs to be to achieve an R38? And it turns out that it really is dependent on the material. So about 12 inches of cellulose can achieve a 38, but anywhere from 12 to 17 inches of fiberglass, depending on the brand and the way it's installed, would be needed to achieve an R38. So at a rough stage of construction, we can look at that area between the top plate and the Iacc Eve baffle, or if they're not baffling, between the top plate and the roof sheathing, and see, is there even enough space there to achieve the code requirement of an R38 over the top plate there? If not, then we need to go back and see what compliance path they're using, because they can't be using a true prescriptive compliance pathway and comply with this requirement of the code. They have to be able to trade off less R value over the top plate and more R value someplace else, or a tighter house or something better someplace else, to keep the equal balance of that energy equation for that particular house there. So again, from an inspection perspective, we need to look at these things at a rough stage of construction. And then the other thing here is that the insulation needs to cover the top plate. So how is that Iacc Eve baffle installed? Is it installed to the back, outside side, the unconditioned side of that top plate, or is it on the inside? If it's on the inside, it wouldn't meet the it wouldn't be compliant with the code, again, because we wouldn't be able to have full coverage over the top plate there. So the junction of the top plate and the top of exterior walls need to be insulated. So this section of the code is embedded in the table, and we know that the table, the air barrier, air sealing, and insulation installation table is a requirement regardless of the compliance pathway there. Therefore, we're guarding against this, what happens when you don't seal that drywall to the top plate that's adjacent to an unconditioned attic space. You can see that if we're standing in the attic looking down at a top plate. The screwdriver is in a rather large gap between the top plate and the drywall. On the other side, the top side there, it's a small gap, but if you add up that gap, the lineal feet of the gap multiplied times the size of the gap, you get a very large hole, and air moving through that hole gets filtered by the insulation, and that insulation turns black, like the picture is showing here. So the code is asking us to seal the drywall to the top plate. You can use a gasket like Seal. You can use other types of gasketing materials. You can use caulking materials to seal that drywall to the top plate. But it's not just the 4 exterior walls. Exterior in this situation refers to unconditioned space, anything that is exterior of the building thermal envelope, outside the building thermal envelope. We've seen some misconstruing of what that word means. It's not the 4 exterior walls, it's to what's outside. So to that ventilated space, which means that all of the interior wall top plates need to be gasketed and the drywall installed differently so that it actually creates a seal there. Attic knee walls are another one of those sequencing mechanisms that we need to think about to get a system that actually performs. So we need a top plate, a bottom plate, side studs, some type of attic side sheathing, and then interior drywall to create that 6th side. Again, this is the requirement of the framer so that the insulator has the proper assembly prep work done that they can insulate it properly when they come to the house after the framer's done framing the house. We do come across some of these scenarios where we're starting to see trusses define the attic knee wall. And the problem with the truss in this scenario is that there isn't a cavity that can actually be insulated. There's not enough depth. There's not a top plate. This is a drywall backing here. There's not a bottom plate. There's not attic side sheathing. And we don't have enough depth to get a decent R value in that assembly. So we should be pointing out that these types of assemblies need to be overframed. In this case, in this skylight shaft wall, it's defined by the truss. They've overframed to the attic side. They've put attic side sheathing there. So we have an air barrier to the attic side. We have a top plate. They just need to figure out how they're going to detail the bottom plate in this scenario here. We talked a little bit about rim joists and the requirement of the rim joist to air seal that correctly. So you're required to air seal the rim, the sill plates to the foundation. And remember that sill seal is a capillary break, not an air sealing device there. So you want to see some type of foam or caulk at that location to air seal that. But we also need to seal the rim board to the sill plate and the rim board to the subfloor as required by the code here. Just to take, we can just move to this slide here. We see that these are the 3 places where the code is requiring that we air seal this location of the house. Floor cavity insulation is now allowed to be installed in one of 3 ways. Before the 2021, the main requirement was that the insulation needed to maintain permanent contact with the underside of the subfloor. And then choice 2 and 3 were exceptions in the code. Now the code is asking you to make a choice. You can choose to install the insulation in one of these 3 ways. Now the problem with installation number 2 and number 3 is that it's difficult to inspect in the field. How do you get up into the assembly to ensure that these sections along the rim board of that floor cavity assembly has been insulated properly and air sealed properly where these blue dots are located here? So you're going to have to figure that out. And potentially you're going to have to remove some insulation to be able to see it and then put that insulation back there. But that's really what the code is asking us to do, is to verify that these installs have been done correctly in accordance to how the code lays that out. Next, we're going to look at some of these air barrier details. So air barriers behind tubs and shower pans, or in HVAC shafts or double wall assemblies. We want to make sure that the air barrier has been installed well. If additional air sealing needs to be done behind the air barrier, it needs to happen. And then when they fill the insulation in these locations, like this flap here, that this flap gets turned up and then air sealed itself. So all of these locations are called out in the code because this is where your primary interior air barrier, your drywall, is not going to be adjacent to the insulation in the exterior wall. So the code is asking us to install a supplemental air barrier system in that assembly here. Now, for stairways, it's also required, if that stairway is on an exterior wall, that we get an air barrier that goes continuously past the stair stringer there, or underneath the stairway where there's a stair platform. Are they going to insulate that and get the air barrier behind there? How do we air seal connections between stairways and garage scenarios there, if that stairway penetrates into the garage? Well, we can put a supplemental air barrier there, or we can run the drywall completely past that assembly there to get the right assembly detail there. Just a couple more that I wanted to show you here. There are lots of issues and lots of inspection points with attached housing and this shaft liner area separation wall. I just wanted to point out that there are new recently published BXUV guides from UL, Underwriter Laboratories, that are now allowing us to air seal these assemblies. This gap between the drywall area separation and the framing that's holding that up. We're now allowed to air seal that, so we need to be looking for that air sealing as well. Otherwise, these assemblies aren't going to be able to meet the air leakage requirements. Manual J and heat load calculations. How are we inspecting for these? Are we inspecting at a from plan scenario to ensure that we have the right design temperatures, for example, that we have the right building assembly components for that? And then what do we look for in the field for these scenarios? These are all questions that we need to be asking here. Same with whole house mechanical ventilation. We need to have them determine what type of ventilation. Are they using supply, balanced, or exhaust ventilation at a from plans stage and plan review? And then in the field, how has it been installed from a spot ventilation perspective, as well as from a perspective of whole house controlled mechanical ventilation? So let's ask our last poll question before we wrap up here. What fundamental questions should we ask when we perform field inspections? And while you're answering that question, I happen to get a text with regards to sampling from an inspection perspective. Sampling generally is thought of when you're looking at a air leakage or duct leakage testing there. And sampling means that you're testing one in a batch of maybe 7 or 5 or 7 houses or 7 units. And if that one unit passes the inspection, then all 7 units pass in that inspection. So it's generally done with multifamily housing that's sharing a common bigger building thermal envelope. But sometimes you'll see sampling that's allowed, especially for program compliance like Energy Star or Lead for Homes, for single family homes as well. In general, the code does not allow sampling. In the 2015 and below, you're allowed to sample using the simulated performance path for multifamily, for specifically blower door testing. But otherwise, you're not allowed to sample. And then in the 2021 Iecc, all references to sampling have been removed. But I just wanted to bring it up, not only because of the question, but because it's likely that if you work for a jurisdiction that you're going to be asked about sampling and the ability to sample specifically duct leakage testing and blower door testing in our houses here. Okay, so everybody said, really the majority of people, 97% said, is it there and does it work? Yeah, that's what I'm trying to get at here, is that we're trying to ensure that our assemblies are actually performing as they've been installed and constructed there. So our inspection process is really happening at plan review, at a field inspection perspective, and then at a really at a rough inspection perspective, and then at a final certificate of occupancy perspective. We're doing some level of inspection at final before we issue that certificate of occupancy. But if we can incorporate this notion, this philosophy of is it there and does it work, then we're going to have an inspection process that is really working well with the intent of the Iecc to create houses that perform and perform well here. So thanks so much for joining us today. I'm happy to stick around for a while and answer any questions or talk about anything that you'd like to talk about. Otherwise, please feel free to reach out to me directly. I just wanted to throw out there that I'm doing a deep dive into the Iecc on Instagram. So you can follow me at Built Tank Inc. on Instagram and get more information about the Iecc in kind of small, understandable snippets. And I'm also doing a podcast on Apple, Anchor, or Spotify. So it could be fun to listen to as well. So thanks again.
Thanks, Robbie. It does look like we've got a few questions and some raised hands. So let's just start from the beginning here. What is cost compliance? And I think that was referring to one of your
Yeah. Thanks for asking that. I'm sorry I didn't make it clear, but cost compliance is the metric that is used to demonstrate compliance with the building performance or simulated performance pathway. So you demonstrate a cost, you have to create a cost compliance report to demonstrate compliance to get your building permit, and then again, a confirmed one at final to get your certificate of occupancy.
Great. Could you explain the changes through code on combustibles room?
Yeah, so I see here someone's wondering about gas cooking appliances. Those are not what this section is looking at. What it's looking for are atmospherically vented water heaters or furnaces that the burning chamber is open to the conditioned space of the house, where you have the potential for backdrafting that appliance and getting combustion safety issues in the house. Those types of appliances are required to be put into a sealed room that is separated from the conditioned space of the house.
Perfect. To confirm, all performance paths requires LTO.
Okay, so LTO stands for leakage to outside. It's a duct leak. It's talking about duct leakage to outside. Yes, if you are using the building performance path and or the ERI compliance path, you would be also doing a duct leakage to outside test in those pathways. But if you're using any of the prescriptive pathways through the code to demonstrate compliance, you are not required to do a duct leakage to outside test.
Thank you for that clarification. And then another one just says UA path ? Guessing he's wondering.
The area weighted alternative pathway is a pathway that's described in that prescriptive section, that R402 section of the code. It's one of the 4 pathways that are allowed in that section. So again, you have the UA, you have the true U value pathway where you're prescriptively choosing to use that pathway. It says you have to put this assembly U value in that location. It's kind of a thou shalt do pathway. You have the R value pathway, which is telling us this is what R value you have to put in your cavity. You can't trade it off. You have a R value assembly pathway, and then you have the UA compliance pathway, which gives you the ability to trade off. That would be using a software like ResCheck software or RemRate or Ecotrope or Energy Gauge, for example, those types of softwares do that UA compliance.
Okay. Can the insulation installer use spray foam insulation in the rim joist to both seal for air infiltration and R value?
Yes. Yeah, we're seeing a lot of builders move to that and move to using spray foam really only in that location in some cases. Yep, you can totally do that.
Great. Attached products, new ICC call out that we can picture, frame, air seal. Where can we find this?
You need to go to what's called the BXUV guide in the for that particular assembly. And I might have one up here. I can pull one up here in a second. And in that BXUV guide, it talks about how you actually construct that wall. And then it tells you that you can use air sealing materials, specific air sealing materials to install, to air seal or picture frame that assembly. Here's an example of a BXUV guide, if you can see the screen here. And it goes down through the specifics of the assembly, and it talks about different ways of constructing that assembly. This is the typical shaft liner area separation wall that we see here. And then when you get down into these numbers, you can look further down here and it tells you what each of these numbers refer to. And number 3, for example, refers to the 2 layers of 1-inch gypsum board liner that separates the 2 units. That's the true fire barrier between the 2 units. And then you get down here to number 8, and it says, now this is new to these guides. It says caulks and sealants, and it says you can use Knauf Eco Seal, or down here you can use a DuPont product or another sealing product to seal it. It's not intended to be a draft stop or fire blocking material, but you can air seal that gap now, and then put the fire blocking like fiberglass or rock wool on top of that material there. So that's where you would look for that assembly.
Thanks, Robbie. Patrick followed up on a cost compliance, cost materials installed or cost of energy needed to heat or cool, and that's energy cost, right?
Yes, it's energy cost, yeah.
Okay, great. And then one more typed question, and then we do have a raised hand. What material do you recommend using for an air barrier? Would a Hvac type covering material work?
Potentially a Hvac could work, but when we're talking, the majority of times when the code is talking about an air barrier, it's talking about that supplemental interior air barrier that's taking the place of drywall that's not adjacent to the insulation. So a rigid material works much better than a flexible material in that case. And I think that builders are having their best results with thermoply, which is a foiled face cardboard type material, or OSB or drywall or those types of materials. Hvac is really a weather resistant barrier that's installed on the outside of the house that can be a supplemental air barrier to your primary exterior air barrier, which would be your OSB sheathing or plywood sheathing on the exterior of the house there. So I would recommend thermoply.
Thank you. Okay, and I've got a raised hand from Muhammad. I'm going to go ahead and allow you to talk. If you could unmute yourself and ask Robbie your question directly.
Sorry, it was by mistake. Thanks.
Oh, okay.
Sorry.
No problem.
Thanks.
Well, then I think that's all the questions that we have today. Thank you again, Robbie, and we hope to see you next week.
Patrick had a